Welcome to EDU World Space.
In this exercise, we have a system of pulleys as shown here in the picture. We have block A that has a mass of 50 kilograms and block B that has a mass of 15 kilograms. And the string represented in blue here is the same string. So the same string that connects block A to pulley E connects pulley E to pulley D and pulley D to pulley C. Okay, so before actually solving the exercise, let's just make a couple of comments about how to solve problems that involve multiple pulleys. First, we need to remember that the tension in the same string is the same, meaning that the tension propagates throughout the string. Okay, and in this we assume that the string is massless and also that the pulley is massless. Okay, and second of all, we need to consider how the height, the changing height of block B and the change in height of block A are related. Okay, because notice that the string length is constant, meaning that if block A drops by a certain height, block B will be raised by a certain height, but these two heights are not necessarily the same. Okay, so these are 2 points to keep in mind when working with a system of pulleys. So let's dive into our exercise. Basically, we have the information that the two blocks start at rest, and our goal is to find what is the speed of block B, okay, after a time t that is equal to 2 seconds. In order to find the speed, I'm first going to find what is the acceleration of block B. And with the acceleration, we can use the formula that the speed is equal to the initial speed plus the acceleration times the time t. Okay? So what do we need to do in order to find the acceleration? First of all, I'm going to apply the first principle that I wrote here. The tension is the same throughout the string. Okay, so basically, I'm going to draw a free body diagram for both blocks. So let's start with point 1. Consider that we have block A here. Notice that block A has the tension of the string pulling it upwards, and also the gravitational force pulling it down. So we have MAG. Now, Newton's second law tells us that MAG minus the tension T is equal to the mass of the block times the acceleration of the block, which I'm calling AA. Okay, this is the equation that comes from the free body diagram for block A. Now, for block B, we also have the gravitational force pulling it down. So we have MBG, but we have 3 parts of the string pulling the block up. Okay, and since the tension is the same all along the string, so we have 3 times the tension. So in the end, we have 3 times T minus MBG is equal to MBA. MBAB, because AB here is the acceleration of block B. So we have these 2 equations which I'm going to call 1 and 2. I'm going to copy them down here. So I have 1, that's m a g minus t is equal to m a times a. And then we have 3t minus mbg is equal to mb ab. So what I'm going to do is multiply equation 1 by 3, and then I'm going to sum both equations. So we're left with 3 mag minus mbg is equal to 3 ma aa plus mb ab. Okay, so let's save this equation. Also, notice that when block A drops a certain distance, which I'm going to call delta xa, block B is raised a certain distance, which I'm going to call delta xb. But notice that there are 3 parts of the same string attached to block B, meaning that when block A drops a distance delta xa, this is equal to 3 times the distance delta xb that block B raises, by which block B is raised, I'm sorry. So this means that the acceleration of block A must be equal to 3 times the acceleration of block B. Okay, so I'm going to substitute this into the equation that we had before. So we had 3 mag minus mbg is equal to 3ma times 3ab plus mbab. So we have 3ma minus mb times g is equal to 9ma plus mb times ab. So ab is 3ma minus mb g divided by 9ma plus mb. Okay, so AB is equal to 3 times MA. MA is 50 kilograms minus MB, which is 15 kilograms, divided by 9 times 50 kilograms minus, actually plus 15 kilograms times 9.8 meters per second squared. This means that AB is equal to 2.85 meters per second squared. This is the value of the acceleration of block B. So the speed of block B is equal to V0, which is 0 since the block starts at rest, plus the acceleration times the time. Okay, now the time is 2 seconds. V is 0 meters per second. V0, I'm sorry. AB is 2.85 meters per second squared, and we have to multiply it by 2 seconds. So this is equal to 5.7 meters per second, which is the speed of block B after 2 seconds, which concludes our exercise.